Hello everyone and welcome back to another video in our Power PE problem solving series. So here in this example we have a single phase load served by a 6.6 kV single phase source. When the load impedance XL is 10 ohms, a fault current of 500 amp is observed over here at the fault. If the fault needs to be reduced by 400 amp, now the question is asking to find the additional resistance value to be added to the load in order for the fault current to be reduced to 400. So first things first, what do we know and what do we not know? So here we are given the value of the load, I guess reactance, impedance, whatever. I'm using those terms interchangeably for the sake of simplicity. So here we have originally a fault current of 500 amp, right? So if we have a fault current of 500 amp, what do we know and what do we not know? So just from a circuit analysis standpoint, the current flowing through here is basically your voltage divided by the sum of your total impedances, series impedances. So we have for the 500 fault, we are going to solve the unknown, which is it is reactance over here, the series reactance to the load. So we have 6,600 volt divided by x plus 10, right? So if you solve for x, this will give you 3.2 ohms. So with the given knowns, we have solved an unknown, right? So this is .2 ohms. So now moving forward with the problem, if the fault current now needs to be reduced to 400, what is the value of RL? So let's kind of redraw and ignore this line over here. I couldn't erase it before I start the video. So let's redraw this right here and so that you can kind of visualize what the question is actually asking you. So now if the fault current needs to be reduced to 400, what should be the value of RL? So now this is what we have. Let me use a different color just to kind of play with it. So now you have a source, same thing, right? So for the load, instead of now having just like a, load sort of, it's split, right? You have a reactance and you have a resistance value, right? So this is still your 3.2 whatever. This is your 10 ohm and this is RL. This is actually what the question is asking, as you can see from here. So don't get confused by what the question is. So again, if the fault is reduced to 400, so same thing, right? So let's call this whole thing, let's call that, the series impedance, let's call that Z, right? Because now we have our reactances and we have kind of apples and oranges, sort of, but we have a resistance value and we have the X values, right? So this still, for us to have a 400, right, we have I is equal to V over Z. So this is still 6 divided by Z, the total Z, right? So let's call the sum, the total series impedance here, let's call that Z. So therefore Z is equal to 600, why I'm still saying 600, 6,600 divided by 400. So this is 6.5 ohms, right? But remember that Z is equal to r plus jx, right? And for us to get the value of r, remember that z squared is equal to r squared plus x squared. So therefore r is equal to square root of z squared minus x squared. But what's x? X is, well, let's just put x squared here, right? So r is then equal to square root of z squared, which is 16.5 squared, minus x is actually 3.2 plus 10, right? Remember? 3.2 plus, so you add your reactances together and then your resistance values together. So when you do the math over here, don't forget the squared, we get 9.9. So this is your actual final answer. Now let's solve this problem the wrong way. See over here, in the multiple choice answers we have 6.5. So the PE actually is very tricky in this sense. So let's say I just solve this problem and I get 6.5, you know, kind of rounded down a little bit, and I'm thinking, okay, I get it because I have a 16 point whatever here. That's totally wrong, because you're not solving for what the problem is asking you to solve. So that's one thing to remember, to understand what exactly the problem is asking, and draw it on your own so you can visualize it. If you actually for instance, if you don't let's see here, 6, okay, so there's different ways that you can actually get this. I did it earlier, but I just can't remember right now. But just be really careful on how to. I'm probably gonna do it on another video, on part 2 of this video. I'm gonna solve this wrong so that I can show you. To just because you have an answer on your multiple choice doesn't mean you have to check yourself, basically. So I'm gonna do, just to not make this video long, I'm gonna stop here. This is your final answer, but I'm gonna put part 1 for the title of this video, and I'm gonna come back and I'm gonna solve it the wrong way, you know, just so you can see what I'm talking about here. It's kind of hard to, because I can't remember how I did it to get one of these answers. I think I got actually all, there's a way that you can solve it wrong, quote unquote, to get each one of these answers. So I'm going to do a part 2 video on this, so you can see how to not solve the problem. All right. So let me know if you have questions on this particular problem. Thank you.